Hi everyone. Today's video is about the question on your screen. How many integral solutions exist for the equation xy plus x plus y is equal to 53? So this is one equation which belongs to the category of special equations, and you would be surprised to know that there is a proper method to solve such equations. Because I have seen such questions being repeatedly asked in entrance exams, I am sure that you will have a certain edge over your competitors who don't know about this method. So first you may try it out on your own, and once you are done, let's discuss. So first of all, I would quickly help you revise what the question means by integral solutions. This term has two parts, integers and solutions. So I will quickly elaborate on both. Well, all countable numbers such as 1, 2, 3, 4 and so on, we also call them natural numbers, are called positive integers. Add to this the number 0 and we get the set of non-negative integers. Add to these the negative counterparts, numbers such as -1, -2, -3 and so on, and we get the complete set of integers. Next, what do we mean by solutions? Well, any combination of x and y for which the equation is satisfied is called a solution. For example, if we take x is equal to 2 and y is equal to 17, let us put these values in the equation and see if it holds. So 2 into 17, that is 34, plus 2 plus 17 is equal to 53. Wow, this is indeed a solution. But remember, any arbitrary combination won't work. I gave you a correct solution in my first attempt only because I had solved this equation beforehand. Secondly, very important point to note is, such equations need not have only one solution. They might have many solutions. And exactly how many solutions? That's a question, right? And to know our answer, we have to solve it. Using trial and error won't work always. Now let us come to the proper method of solving this question. So first step is to add 1 on both sides. This will help us factorize the left hand side. In general, remember that to find integral solutions for an equation that looks like xy plus ax plus by is equal to k, where k is some constant, we must add a into b on both sides of the equation. And the rest of the steps are exactly the same. Over here also, the coefficients a and b are equal to 1 and 1. So we are adding 1 into 1, that is 1 only, on both sides of this equation. Okay, next we club the first two terms and club the next two terms. Take x common, y plus 1 in brackets, and for the second pair, nothing is common, so we write 1 into y plus 1. Thus we get two terms. X plus 1 into y plus 1 is equal to 54. Both equations are the same, only we have rearranged the terms to suit our needs. So this is the equation that we need to solve. X and y should be integers. Looking at it, the first thing that comes to mind is, in how many ways can you write 54 as a product of two numbers, these two numbers? Also, one more observation, that is, if x and y are integers, then so are the terms x plus 1 and y plus 1. They are both factors of the number on the right hand side, which is 54, isn't it? So next we would like to know how many factors of 54 exist. Now 54 is a small number. We can directly write down the factors without missing any of them. But still, it helps if you quickly prime factorize the given number. I am drawing out a factor tree here. 54 is equal to 9 into 6. 9 can be further written as 3 into 3. Both primes are the end nodes, so we stop at this branch, and 6 can be written as 2 into 3. So 54 is equal to 2 raised power of 1 into 3 raised power of 3. This helps us write down the factors. Always remember the smallest factor. It is 1 for any number. 54 can be written as 1 into 54. Both of these numbers are factors of 54. the next factor. So 54 is also equal to 2 into 27. 3 is the next factor. 54 is equal to 3 into 18. Next factor is 6. 54 is equal to 6 into 9. Beyond this point, the factors start repeating. So 54 has how many factors? 8 factors. And this is the list. Now here comes the spoiler. This equation has double as many solutions as the number of factors. But you would like to know why and how, isn't it? So let me list down all ways of writing 54 as a product of two factors. We know there are 8 factors. So there are 8 ways of doing this. Each of these 8 ways gives us a potential solution because we can equate the first term, which is x plus 1, with the first factor, and the second term, y plus 1, with the second factor. The combination of x and y that you arrive at will certainly satisfy the equation. For example, let me pick this one. If x plus 1 is equal to 6 and y plus 1 is equal to 9, solving these two equations, we get x is equal to 5 and y is equal to 8. Let's put them back together in the equation. 5 into 8 plus 5 plus 8 is indeed 53. But as I said, this equation has double as many solutions as the number of factors. It has 16 solutions. Do you want to know where are the remaining 8? Okay, so I will give you a hint here. The product of two numbers, look at the right hand side. It is positive. 54 is a positive number. It is positive in two cases. Either x plus 1 and y plus 1 are both positive or both are negative. So let us replicate the list with both factors negative. It's the same list, you see, only we get 8 additional ways and therefore 8 additional solutions. For example, if you pick these values, if x plus 1 takes the value minus 2 and y plus 1 takes the value minus 27, do we get a solution? Let's verify. Solving these two equations, we get x is equal to minus 3, y is equal to minus 28, and putting them back in the original equation, minus 3 into minus 28. Minus 3 minus 28 is equal to 84 minus 31, which is indeed equal to 53. So that proves the point that this equation has double as many integral solutions as the number of factors. Now sometimes we have a slight variation to our question that I would quickly discuss. Instead of integral solutions, if they ask you how many positive integral solutions exist for xy plus x plus y is equal to 53, how does our answer change? Well, the steps to solve the question are exactly the same, only we need to account for this additional constraint that x and y are greater than 0. What does it imply for these two terms on the left hand side? Look carefully. If x is greater than 0, then x plus 1 is greater than 1. And if y is greater than 0, then y plus 1 is greater than 1. This means the negative pairs are completely out. Further, both are greater than 1. They cannot be equal to 1. So we drop this combination and we drop this combination. Therefore, for this question that x and y are both positive integers, there are only 6 solutions possible. That brings us to an end of this video lesson. Hope the concept is clear to you, and from now on you can attempt these questions confidently. If you enjoyed watching this video and found it useful, do press the like button and subscribe our channel for related content. Here is a glimpse of other maths videos on our channel. Stay tuned and take care. Bye-bye.